long time no see. I hope you were able to dive into some of those exercises. And I think what I want to do for this session is I figured out what I did wrong in that, sometimes when you're working through a notebook and you go back and forth a lot and you're doing this, doing that. Okay, why did this needs to work here? This needs to work here. And then then you run through it all and it works and you're like, perfect. And then you restart it. And then when you restart it, all the things that were there that you didn't remember being there are gone. And then things like not being able to print because you're referencing the wrong model pop up. So I updated the Colab notebook. Great thing about being able to push this out real fast. I had a single M there, so I was referencing model M. Above, I said model MM, and I forgot that other M. So when you change that and then you run through, this is what you get. As you can see, you can look at the, again, this was minimizing cost. So we were minimizing cost amongst 4 scenarios. One was the base case, so we already knew that number that was there before. And then the increased price scenario, where we had sort of higher peaks and lower valleys of prices, increased obviously the overall price, which makes sense. Lowering the battery capacity, so saying we can't store as much. Obviously, it makes sense that the price increase there because we just have to buy more electricity overall. But the high solar scenario where we had much more solar availability, that had a pretty substantial decrease of the cost, because again we were allowing this model to directly use the generated electricity from the solar panel, as well as being able to store and then discharge. So because of that capability that we allowed into the model to work that way, that extra solar availability was really good to limit the cost there. So if you were to remove that functionality and solely rely on the batteries, then things would be a little bit different. You would eventually at some point, the solar availability, the more that you have, you're not going to really use it all. You would reach that maybe a little bit faster under a scenario like that. Actually, part of the exercises is, hey, how do you turn on and off variables? Now that I'm saying this out loud, this would have been a good example to do there. So there's homework assignment. Turn off because again, the gen decision variable is how much of the solar, how much energy you're taking directly from the solar panel and using it to satisfy demand. So it's not going through the batteries, it's going straight from panel straight to satisfy demand. Homework assignment, turn that variable off in a scenario and see what happens. There's other scenarios that I outlined in the exercises that we're going to go through. And you can add that one for fun. And since everyone's here coding away on a Friday, learning optimization, I think it's safe to assume that actually would be fun, because that would be fun for me. I'm going to do that. And maybe I'll update the notebook to consider that, or update the exercise set to consider that as well. So if you come back to this stuff later on, you'll be able to like, oh yeah, that was a cool problem. So let's dive into the exercise set. I think part of me rambling here was to talk about this and go through these scenarios again and talk about why we got what we got, but also to give you a little bit more time to complete these exercises. This is a shorter session, so we got about 10 minutes left here. I think that's a good time to dive in to the solutions to the exercise set 2 and talk about some of these as well. So exercise set 2, question 1 is, we have these charge and discharge constraints about limiting the flow in and flow out of the batteries. We have binary variables that help us mirror that, because we're not allowed to charge and discharge at the same time. And I guess one thing about optimization models is it's very much a give an inch, take a mile type of thing. If you allow an optimization model to cheat in the slightest way, it's going to exploit that in the most incredible ways. So another sort of, I guess, lesson about optimization modeling, if you're getting started, is if you get some weird solutions, that doesn't mean that you're far off from actually having things modeled correctly. It could just be one tiny little thing that you're not incorporating, or hasn't been told to you, or whatever it may be, that will lead to some really, really crazy solutions. So keep that in mind. Okay, so question one. Now I'll get back to the question. Let's rewrite this constraint using the indicator. So again, this happens a lot. Let's we need to have the indicator be the if part of the indicator be a binary variable. So we essentially, again, what these constraints are saying is, if I decide to charge, or excuse me, if I decide to charge, then Z is 1. If I decide to discharge, then Z should be 0. So flip that stuff around, do contrapositives, and here are our constraints, using the indicator functions as well. So in this particular case, there's probably very little difference performance-wise between the two, and this, so it's still, to me, so even though this is very concise, I think both methods are pretty good here. But part of the lessons of using big M's and stuff like that is you can get into some problems. So I still stand by the statement of, when you can use stuff like this, go for it. It's the safer choice. So I put all the code down here instead of blocking it off. So the rest of the questions are talking about some tips and tricks for what you can and can't do with the multi-scenario API. So for example, you cannot explicitly say this variable is now in this scenario and this one's out. So you can't add var between scenarios. You can't change variable types. And you can also you cannot change the sense of constraints or add constraints and things like that. So you can't, again, add constr, add constr. You can't do that between scenarios, but there are ways to get around that. So let's assume that we've already done the scenario. We always do the scenario number and scenario name stuff that we're talking about before. Let's not worry about that. But question 3 says, okay, if you wanted to remove a variable, set its bounds to 0. So if you have a decision variable and its lower bound is 0 and its upper bound is 0, then it can only be 0, and it's essentially like it's out of the picture. So that's an effective way of removing a variable, is just by setting it to 0, and then it's just gone. So question 3, write a for loop and Gurobi Pi code to remove that. And to remove the flow in and flow out for battery 0 in time periods 0 to 49. So the first 50 time periods. And this is what the code would look like. We have our flow in and flow out for battery 0. We loop over time periods, and then we say the upper bound is 0. We don't need, if you wanted to specify the lower bound to be 0, you can, but it's already, it's already a default. So we don't need to necessarily specify that. 5 minutes left. All right, good timing. So if you want to add a variable, you do the opposite. You initially set it equal to 0 in the base case. Set the bounds equal to 0 in the base case, and then change the bounds accordingly afterwards. So we wanted to write a variable w and we initially specify the WT, specify the lower bounds and upper bounds to be equal to 0, and then update in a new scenario, say the upper bound is equal to 100. Question 5 is relating to the VBT variable that we used. Suppose we had a hard constraint on the number of times that we allow this violation. So let's write that. Let's code up that constraint saying that the number of times that we violate our depth of discharge must be less than or equal to some constant C. And let's call that value C15. Add a all right, add a constraint for that, and then add a, oh, actually, yep, sorry, that I was misreading my own code. Add that constraint, and then add the scenario code to make that constraint go away. So here is our variable, and here is our, again, you don't have to do this summation part. I kind of like it now. So this is our original constraint saying that the depth count must be less than or equal to 15. And then now to get rid of that, this is a single constraint. To get rid of that, then we just change the right-hand side. It was 15, now it's infinity. So we say, hey, it could be whatever it wants. You can change it to another maybe number if you'd like to. That would never be possible. Think about what the lowest value of C could be if we have binary variables for B and T. That's a good sort of thought exercise. Think about what that would be. And there we go. So that was our running through our second exercise set. If you have any questions, post them in the Q&A feature. And we're just a few minutes before, I think we have a break next, actually. So we can start our break a little bit early, and then we're going to get into a super awesome, super cool problem that Asan put together. And I'm excited for it. I'm going to have my popcorn ready, and paper towels, of course, to wipe my hands so I don't get butter all over my keyboard. Okay. All right. See everyone in the next session.